So first thing that we need to do is we need to go on to the Earth Data website and just familiarize ourselves a little bit there. During the Hack Week, you're not going to have to go there very often, I think, but it is helpful to orient yourself to the data. Okay. So we are using this path. Jeremy talked about, the level 3-4 browser. You can also get some data on ERDAP, but we're going to be using this NASA Earth data, and we'll be connecting to that via Python. We could download a netcdf, but we're not going to be doing that. We are going to be, generally, we're not going to be doing that. We're going to just be loading data into memory. Okay, I already talked about this. We're going to be using the earthaccess Python library that was developed by the NASA Earth Data team. It's a really fantastic library that makes it very easy for us to access NASA's data that's in the cloud. You're going to be using this all week. So let's start off, though, on their website, just getting a little bit oriented about the data and their data catalog. So we're going to be going to this right here. Oops, back here. Okay, let me put this in the chat. Come on, chat. Okay. So we're going here on their catalog. And when you're here, you're going to click on this search button right there. All right. So now we can search all their data. And in here, let's see which one. Okay. So once you get on there, what you'll see here is you can see all the data sets, and then you can sort of filter it in various ways. And what we are going to do first is we're going to search. So I happen to know a data set that I want you to look at, and I already know the short name. I'll show you. We'll get that. Say, oh, it's not letting me select. Darn it. Okay. Mirror JPL L4 blob. Okay. So I type that mirror JPL L4 blob. And what else did I want here? L4 glob V4.1. Okay, let's go back here. V4.1. There we go. So it brings up a data collection, and this part here that says granules, what that's saying is these are files. It has 8,640 files. It is starting from 2022. It is a sea surface temperature product, very well-known one. And I can click, oops, oh, didn't want to go there. All right, let's go back. Okay, great. Okay, so once I'm here, I clicked on there, they're showing the data files. That's not so useful. Instead, what I want to do is when I get there, I want to click on this I. And when you're here, it shows some key information about the data set. It shows the IDs. So it has the name here, but look here. This right here is what's called the short name. This is the DOI. We can go click here and get some more info. So if we need to know more details about this data set, the data here is very well documented, so it's really great. You'll find, all this like great information, tools, all about the variables and documentation. And importantly, also, you find the IDs. So it repeats the short name. We already saw that on the previous page. And this thing is called the concept ID. We are going to be using the short names for things mainly. Let's go back here. So I showed you how to search by name. We can also search by, hey, get rid of that. Come back here. Okay. Sorry, get back to the search here. Get rid of the JPL. Do not do that. Okay. Okay. We're back at the search. Okay. So we're back at search. We can also search by instrument. So if you go here and say you want the instrument on PACE, it's called OCI, if you remember from Jeremy's lecture. So you can click that. And now you will see all the data sets that are available for here that are available for this sensor. So sometimes that's helpful. You can kind of poke around and just see what the data are. It's often helpful. Let's see, what else do I have here? Yeah, that's the main one that I have worked with is the OCI. So you'll see how to do this in Python also in just a moment. Okay, so let's repeat. The key thing is that we need to have the ID to the data set. And the short names will look like this. DOIs look like that. We are going to be using the short names. Okay. All right. So if you want to play around, I'm not going to go through this right now because I want to go jump into our tutorial and start working through getting data and working and plotting some data using our Jupyter Hub. Okay, so let's get out of there. And now we're going to go back to FishPace and going back to the tutorials. And now we're going to go to the notebook. So here. If you are logged in, let's fingers crossed that this will work. Did it work? No, it didn't work. Oh, darn it. Oh, well. Oh, no. Well, that is very unfortunate. Okay. I'm going to have to give you the link address just a moment. Should have worked, but okay. Let me post this in here. Okay. Here is the link. I will fix this if you want to come back later. I just clearly didn't get that link in there, so you couldn't click on it. But I'll fix that so that when you go to our tutorials, you'll be able to click on this orange thing. And if you're logged into the hub, it'll automatically open for you. Tomorrow, we'll also see how to clone our tutorials into your hub, and you can get to them that way also. Okay, I'm going to pause here for a moment and get a kind of show of hands if some people at least have been able to get in using that link I just posted. Aha, I've got some. Great. Okay, so at least a few of you. Perfect. Okay, so let's go ahead and start here. So we also, by the way, have links to collabs. So if by for any reason the hub is not working for you, all these things will also run in Colab. If you are running things in Colab, however, you do need to uncomment this and run this because there are a couple packages that are not in Colab. Okay, but we're on the Jupyter Hub. Everything's installed for us. So the first thing that we want to do is load up our packages. We're going to use earthaccess and we're going to use Xarray. And we're going to use this shortcut name for the Xarray package as XR. That's just a standard thing. We could call it anything, but it's very standard to call it XR. So I'm going to run that. I've loaded up those packages. The first thing that we always want to do when we are getting the Earth data is we need to authenticate. Now, I have already authenticated, so it has saved my information. The next line for me is just going to work. For you, what you're going to see the first time you run it is that it's going to ask for your username and your password. So run that bit of code. It's going to pop up, ask for your username, put that in, and then your password. If you mess up, just run it again. Once you get logged in, let's see some thumbs up so I can get a sense of that at least some of you have been able to authenticate. All right, we've got one. Yay. Anyone else? Another. Yay. Okay. Just looking for a few. Then I know at least I've waited long enough. Okay, we've got another. Yay. Great. Anyone else? Up, we got another. Okay, we've got to know. How do we know it worked? Oh yeah, I know. It gets silent. It won't say anything. Um, it will complain if it didn't work. That's a good question, James. Okay, and next time you run it, it will act just like it did for me. It'll be silent because it saved it to a netrc file in your home directory. So next, what we can do is we're going to use the earthaccess package and search for data. We can search by instrument using this code here. So it's earth data search underscore datasets instrument OCI. And then we're going to print out all the short names so you can see them. We're doing just the first 20. So I can go into this code and I can run it. It's querying the database, and here we go. So here are the first 20 short names. If you want to see all of them, you can carefully get rid of the square brackets, rerun it. And now you can see, whoa, that's all the data sets I'm going to be able to load in. There's that NRT that Jeremy talked about, near real time. All right, so let's see how we would go ahead and get some data. When you scan this, you're going to see L3M. That is our level 3 mapped data. That's what we're going to be using. And you can also see we've got our level 1, and we have a little bit of level 1C data. I'm going to show you using the level 2 and the level 3M data. This one's on a global grid. The level 2 is swath data, which I'll describe in a moment. So let's look at the level 2 data. So now we're not going to use instrument. We're going to use instead short underscore name and give it the name. So this is the level 2 AOP data. And if we did that, that would be like thousands, like many, many, many thousands of files. So I do want to tell it the time range. So I'm going to look for what are the files for this date for this data set. So let's go ahead and run that. It's just going to take a moment. That didn't take very long. So 143 results. What that means is 143 files. Why are there so many files? It's just one day. Well, swath data is, which we'll learn later, it's like as the satellite is going around, it's not like the whole grid. It's like these like lines as the satellite is making these rotations around the Earth, and they save it in these chunks, like spatial chunks. So it's important when you're working with level 2 data that you say what region you're working in. So in this case, this it's here's the format of the bounding box. So you can give it a lat long bounding box. And this is actually Great Lakes. Run this. And so now we have 3 results. So that's better. So there are 3 of these like spatial tiles on that day for the Great Lakes. Let's check out level 3 map data. So we want the L3M, and this will be a global map, and it's on a 4-kilometer grid. The level 2 is on a 1-kilometer. The level 3 is, it's either 4-kilometer or it's a 0.1 degree. Can get either of them. So let's check this out. Let's see how many files we have for this day for level 3. And there's 16. Wow, why are there so many? Like, it's just one day. Shouldn't there just be one? Well, for level 3, you're going to have monthly data, 8-day data, and 2 resolutions. So it's not enough just to tell it what day you want. So here you can look at the results and you can kind of see, if you look at the data here, it tells you the file. You can kind of scan through this. Ryan showed you these, data file things. So you can see we've got level 3. I'm actually not really sure what SNWI is. Let's look at some.
Winter season.
Oh, it's seasonal data. Okay. So this is R32. What is that? Let's look at something here. Okay. Okay, this is more what like I would, I'd be looking for here. So I'm looking, you can see it's got this. This is your 0.1 degree. This is your 4 kilometers. And then we're going to see where is L3. You see it's got, it's a little hard to read here, but it's A8D. That would be 8-day versus this one's day. This would be your daily data. This one says MO. That's going to be your monthly. So when you're working with level 3 data, you have to do a little sleuthing on the names, and then you'll figure out how to filter the names. And the filtering that you use is pretty standard. So you generally can just use the code that we could give you or just slightly adapt it. So this one, what it's saying is, hey, give me monthly data. So MO, I want you to find MO, and then it's going to have a whole bunch of stuff. And then I'm looking for the 0.1 degree data. So this would be give me monthly 0.1 degree data. Now, when we do it just for this date, we get 1 day. There we go, 1 day. So we have 1 month. So here's the summary. Here's the formats you're going to be using when you search for level 3. You'll be using things that look like this. If you're doing level 2, you're going to be passing in bounding box. You're going to be using one of these, depending on whether you're using level 2 or level 3 data. Now let's go ahead and load in some data and make a plot. We're going to use the level 3, the global data. So here we go. We've seen this form before. We're looking at RRS, so remote sensing reflectance. We're getting it for 1 day in March. We're getting monthly data and 0.1 degree. So let's run that. So if we plot that out like that, it shows us it's pointing to a NC file. That means a netcdf file. And it's not too big. It's 580 megabytes. The second thing we do once we have results is we set up a file pointer. This is data that's in a cloud bucket. And when you're interacting, anytime you're interacting with data in a cloud bucket, you have to set up these file pointers. And earthaccess does it for us. We don't really have to think about that. We just set it up with this file set. So here we go. I'm going to run that. Goes over there, it sets it up for us. Doop. So it set it up. And then once I have that, I can read this file pointer and it looks like this. So I'm going to use Xarray and it says open data set and then I use file set. I'll talk later about what chunks is. There we go. So now what do we have here? We have remote sensing reflectance. You can see 172 wavelengths. We have this many lat and that many long. It's global. The cool thing here is I didn't load all this into memory. Remember, I'm on a really quite tiny little machine here. I only have 2 gigabytes of RAM. But I didn't need to load it into memory. It's lazy loaded. It just has the information about the data. Get attributes if I want to read a little more. That just gives me some background. All right, so how big is this data? Can run that here. So this is my DS, this is my object, and I'm saying, hey, tell me how many bytes it has and divide that by 1e to the 9. So it's about 4 gigabytes. Yeah, I'm not going to be loading that into memory. Okay, so let's review what we just learned. So this is the format you're going to be using over and over again for this hack week. You get your results using a search like this. Then you lazy load in that data so you can look at it. You're going to import Xarray like that. You're going to set up the file pointer, and then you're going to open. Here we're opening one data set. Okay. That's the basic to get this data in the cloud. So let's go and see an example of this where we're gonna plot a little bit. So here we go. We're gonna load that. We already did something similar, but this time we're getting a year. So run that. So now we're going from March to February the next year. So 12. So 12 as we expect. We can look at what the files look like just to make sure they look okay. That's telling us what files it's pointing to. It all looks good. So the second step, we set up the file set. There we go. And now we're going to read in just one of these months first. So let's go ahead and read that one in. There we go. We have one. You can see it's got this variable wavelength. Here's our data set. We can use the square brackets there and look at what the wavelengths are. Oops, where we go. We can see here we are, all 172 of them. And now we can plot. Here's a very simple example of plotting. And let me walk you through what the steps of this are. So this is the data set that I just loaded, this DS1 right up here. So here's where I opened it. I opened that first file and I called it DS1. I'm going to grab the variable RRS. So, and I'm going to call that RRS. Then I'm going to select the wavelength 346. I'm going to call that 346. So I assigned it to that. And then I'm going to use this function called slice to get just a latitude and longitude slice. So I want to go from -90 to -75. And I want to go for longitude and then the latitude 47 to 40. Yes, I realize that looks backwards, but that's how you do it for this. And then I assign that to this sub, and now I can plot it. So let's go ahead and do that. So notice how quick that was. I'm on this tiny little virtual machine. I didn't blow up my memory because I didn't load in 4 gigabytes of data. All I did was load in the little slice of data, this wavelength slice and this lat long slice that I needed. And I plotted it. This code here where I'm doing it line by line, I did that for those of you who Python is unfamiliar, but typically how we do this is something that looks like this. I'd have selecting it and then I'd select and then I'd have my selection code all together like that. And then I could do the same thing, plot that. Okay. So summary, here is that format again for how we load, we search for it, we get our file set, and then we open one data set. In this section, this is optional. You can look through this, run it on your own, and you can see how you could open all 12 months and make a plot. So now 12 months, that's going to be 12 times, 4.6 gigabytes. That's really big. So I definitely could not load that into memory. But I don't have to. I can do it lazily. Yeah, Carol, go ahead.
Eli, I saw a little mistake because the plot you did for explaining those who hasn't experience in Python.
Yep.
Right there, it's RRS is equal to DS. It's missing a one.
You're right. Thank you.
You're
Yes,
welcome.
one. Yeah, there we go.
And the
Yeah.
plot the
Yep.
same. Yes.
Yes. No, it's the same. Yeah. Yeah, I did catch. I was like, that looks a little different. Okay, well, whatever. Okay, great. Yeah. So we can open up all 12 and you notice that went really fast and I didn't, blow up the memory. It has gone up a bit, but that's because I'm plotting. All of this is what's called lazy loaded. It's not loaded into memory until I tell it what I need. And if I'm working with 12 months of data, so it's really big, then I'm going to be doing things like slicing to small regions. You can walk through this code on your own and see how you could make a plot for each month. So this just shows you an example how you can work with really big data sets very easily using these tools, and the format of the code that I showed you is going to work for all your level 3M products. So the same kind of framework. For those who want to work with the level 2 data, level 2 is swath data, and it's not on a global grid. It's a swath is as the satellite is going around the Earth, it will have a number of pixels going this way, and then number of lines going that way. And so it's kind of moving around the globe. So it doesn't have like a set grid of the lat long values. And this data is in a different format. For those of you who are brand new to remote sensing data, I would encourage you to stick with the level 3. But I'm going to show this very briefly for those who do have experience with remote sensing data to see how to interact with this swath data from PACE. So we can give it a bounding box. There are 3 results there. So this bounding box is the Great Lakes, and there are 3 files. We're going to set up the file set again. So that step's exactly the same. What's different about the next step is that instead of saying open data set, we're going to open data tree. The reason is, let's run this. We're working with this level 2 swath data. It is in groups. It has our geophysical data. That's going to be like our remote sensing reflectance, so like RRS. And then it's going to have the navigation data, and that's where we're going to get the lat long data that we need to like put things on a map, because we can't use the pixels. The pixel and the lines is reference to the swath. But when we plot it on a map, we're going to need that navigation data, which is lat long. So we open up the level 2 data using Open Data Tree. If you've been using X-ray for a while, Open Data Tree I think came out last year, and it makes it a lot easier to work with this group data. So we're going to be showing using Open Data Tree. So we open up the group data with Open Data Tree, and then we can use merge, use this merge code right here, set our coordinates, and now we have data that has our data variables. Let's see, where do we go here? What do we have? Yeah, here you can see we've got our RRS, and nicely we have our longitude and latitude. So now we can make nice plots. So here we could do this, make a nice little plot. So we're picking that level 2, the RRS. We're going to select that wavelength. We're plotting it with X longitude, Y latitude. The plotting's a little different here because I think if you look here, yeah, I forget why you have to tell it. It is different. You have to tell it the X and Y, and I forget at the moment why that is. But this shows you an example of plotting it. This is not very pretty. We would like an outline of the Great Lakes. It'll look better. So let's go ahead and run this code. There we go. And now we can show that outline. If this code, this longer code, looks a little daunting to you, all the chat bots are really fantastic at making plots like this. They are so great at visualization. You can, grab our code here and say, hey, this is what my X-ray data set looks like. Show me how to make this plot with lines for the land, and it'll show you the code. So this is the last bit, and then we'll close up for our lectures for today. In the summary, this is that code that you're going to be using with your level 2 data. You're going to search, you're going to open up the results to make that file set, and then you use data tree and merge to merge that lat long data together with your variable data. All right, I'm going to stop there.